Question 5 is a stats hypothesis testing question. I think it's a good idea to begin by highlighting the key points here. So, social media app rated excellent by 70% of its users. Blah, 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 blah. And then there's a sample of 28 customers, and 15 of those rated it as excellent. Okay, so it helps us out a little bit. It tells us it's a binomial distribution. The significance level is 5%. Okay, so let's make a note then. This is a binomial distribution. The sample size is 28. So there's 28 trials, and the probability is rated excellent is normally 0.7. So if we let P equal the percentage of excellent ratings, when we do this hypothesis test, we can say that the norm, what we expect, is that P would be 0.7. Now in this question, you need to read the wording carefully, because it says test where there is evidence to support the claim that the percentage of users who rate the app as excellent has changed. Okay, now the wording is key here. It says changed rather than increased or decreased. So because it doesn't say increased or decreased, it just says changed, we need to do a hypothesis test like this, where it can't be equal to 0.7. Okay, so it's a two-tailed test, worth making a note of that. Two-tailed test. So we halve the significance level and test test 2.5% at each end. Okay, so that's key, that it's a two-tailed test, this question. Okay, so if we just have a look at the question again, what it says up here, it says 20 out of 28 customers, 15 rated it as excellent. Now if we had 28 customers, we would expect 28 times 0.7, that's 19.6. So we'd expect 19.6 customers to say excellent. By the way, this really isn't part of the hypothesis test. It's just going to help us decide which end to test. So we'd expect roughly 19 or 20 customers to say excellent out of 28. But we've only got 15 saying it was excellent. So 15 is lower than we would expect, lower than expected. Okay, now because 15 is lower than we would expect, we don't need to test at the upper end of the scale. We just need to test at the lower end, okay, because clearly 15 out of 28 isn't higher than we would expect. So we just need to test 15 or more extreme examples. So if it was 15 or even lower than that, that's what we need to find. So if you use the binomial cumulative table on your calculator, you should find that the probability of that happening is 0.049. Okay, now remember we've halved the probability level, and so that is greater than 2.5%. Okay, so because that's greater than 2.5%, it's not that surprising, it's not that unusual. So therefore we do not reject the norm. Okay, so you can say there is insufficient evidence. Always put this back into context. So you can say there's insufficient evidence to suggest that the excellent ratings has changed, to suggest that the percentage of excellent ratings has changed. Just ran out of space. Has changed. Okay, looking at part B then. It says Derek, one of the owners of the app, was against the introduction of the new features. He claims the percentage who rate the app as excellent has dropped to under 55%. Comment on whether Derek is correct. So he thinks it's gone down to under 55%. Now, if you work out 15 out of 28 as a percentage, I think that does give you less than 55%. So that's probably what Derek is thinking. So for the answer to this question, probably say that Derek thinks this. Derek thinks this because 15 out of 28 is 53.8%, which is less than 55%. So that's what he's thinking. However, the test has only shown that P hasn't changed. Okay, so our test was just to check, has P changed or has it not changed? And so all we found from our test was that P hasn't changed. Our test didn't show that P has fallen, or certainly not fallen below as a particular specific value. So I'd probably say for the answer here, I'd probably say that the test we just did only confirms that P hasn't changed, not that it has fallen. Okay, as I said, certainly don't know that it's fallen below a specific value. So I think that would be enough to get your 2 marks for that question.